had not remembered to start recording. Now we're recording. I'm sorry. Now, what were you about to say, Chloe?
Then you would need 2 nitrates to balance out.
Beautiful. Right? You might have to do this for all of them. Because the words part has got to have meaning over into the chemical equations part. And then eventually, you've got to start to see that as, let's see, copper nitrate. Okay, I kind of know what that thing's going to look like. It's an ionic solid. It's going to dissolve in water very easily, so this reaction probably taking place in water. Okay. What about the other parts? Sodium hydroxide, what's that? You guys saw that in lab, right? What is it? Sodium is Na, by the way, if that helps. Our periodic table hanging on the wall in here does not have the words with them. But Na. OH, very good. Okay. What about copper 2 hydroxide? Hint. Okay. And then sodium nitrate, that's a little easier now, right? Because we know that that's a nitrate, right? Okay? Yes? Y'all remember how to do all that, okay? Well, that stuff is what you need just to get started. Okay? So now I'm going to give you a little bit of a cartoon version here. I'm going to get the thing out of the way, though. Try to get that thing out of the way. Okay. So consider this little blue sphere to be the copper, okay? And then a nitrogen surrounded by 3 oxygens, that's a nitrate. We need 2 nitrates, right? Okay, cool. We're going to react it with a sodium hydroxide. You can guess which piece is which here. That's still the oxygen. That's a little bitty hydrogen sitting on it, right? And there's our sodium. We're going to react that. We're going to change who's paired with who. Right? We'll talk about the type Thursday. So now we have copper hydroxide, right? And it balanced differently, right? Because the copper is 2+, so it needed 2 of the hydroxides. The sodium. So look at this and tell me what problem you see looking at my cartoon drawing. What do you see here? There's a problem. So, where did that hydrogen come from? What else? Same sort of thing. What else?
There's no
Nitrate? All right, so we got one, but then where'd the other one go? Okay, so this gets the idea of balancing equations, which you guys I'm sure have seen before. But this is the point. Okay? You might consider yourself to be a greater power in the universe, but you may not destroy or create atoms. Okay? So you can't just randomly create this. You've got to account for it. Every atom that is at the beginning of your equation must be at the end of your equation, no more and no less. Exactly the same atoms. So we need another nitrate over there, right? We need another of those. What did I do with the other? There it is. Okay. So how do you think we would balance this? What would I put in the original equation? Symbology-wise.
Could you multiply the sodium hydroxide by 2?
So I would put a 2 there. And 2 sodium nitrates. Please do not forget that if you don't put anything there, there is a 1. Okay? That's Val's equation. How many of you have done this before? Okay, yeah? Like in high school chemistry, maybe? What was your approach? How did you do it? Anybody at home got an input on this? I know you guys can hear me, right? I hope you guys can hear me. Oh, there's a chat again. Who's what's in chat today? Yay, Rachel. Thank you. I didn't see it before. Yeah, Zach, I hear you. Okay, so there are different approaches, and I'm going to talk about 2 of them at least today. I don't really intend to talk about the 3rd one unless, Jonathan, maybe you got the chat monitoring going on?
Yeah, I can jump over.
Okay, thank you. That way I don't have to switch back and forth. Wow. Where's the rest of my? Thank you. All right, I need to ask this. Are any of you absolutely in love with doing things mathematically? Because there's a 3rd way of balancing these things that 99.99% of people do not like. And it is solving a system of equations. So there is a way, and I can show you that if you're interested, but I don't bother with time on it if you're not interested, because most people are not. Okay. All right, let's talk about terminology on it. So I'm going to throw a lot of terminology at you in this next section, this week and next week. That's the reactant side of the equation, and that's the product side of the equation. Okay? Terms that go along with that. Those are reactants on this side, because they're on the reactant side of the equation, and those are products on that side. Okay? And the little number that we just put in front of stuff to balance it is called a, where'd it go? Coefficient. All right? The other one's a coefficient also. This is I stole this as a figure straight from your book here. Be familiar with those terminologies, because I'm going to ask things, and I don't mean to confuse you. I'm just not thinking about it because I use these terms all the time. Oh, didn't talk about this before. So, see that parentheses up there? These are phases, all right? So what do you think in an equation if I put, let's see, if I put a little g in front of this methane here, what do you think it might be? It is a gas. That's at whatever conditions your reaction is running at, okay? Methane is a gas at most pressures and temperatures you will ever work at. Unless you're doing some marine chemistry stuff, there's a big thing going on with methane hydrates at the bottom of the ocean, they're solid phase. GS is going to be solid. L is liquid. I'll usually do that as a cursive L. I think that's just old school. I don't know why. AQ. Anybody know what the AQ part is? Aqueous. What does that mean?
Water.
Has to do with water. What with water? Yeah, it's dissolving. Most of the chemistry that we'll deal with in this course is going to be aqueous chemistry. It's dissolved in water. Now, if you take orgo, then that'll change some. It'll be dissolved in organic solvents a lot of times instead of water. Okay. XLL, I might use that occasionally. It means crystalline. So if you see actual little crystals. Sometimes I just put solid. Other times I might say actually crystalline. That'll matter more next semester when we talk about the energy of crystallization. Oh, wait, is that next semester? No, that's this semester. That'll matter later this semester. All right. So we're going to press them together. You know what's coming. I got some creative already running. You're going to have to do one in a minute, okay? Maybe we can start signing your phone if I got to. Y'all just put your names on this. I need to do a better job about signing in. You don't have to sign it like a doctor. Make it so I can read it. All right. Who's got a thought on how we go here? What do we do here? What's your approach? What are you doing? What's going on in your head? Give me words as to what you're doing in your head looking at this thing. You have two oxygens on this, on the which side? What do you call this?
On the left side.
What's the left side called?
The reactant.
Reactant side, okay. So we have two oxygens on the reactant side, and therefore what?
We need two on
Product side, okay, cool. All right, so how can we get this? All right, so you would, let me see if I put these up here already. I didn't. So say it again. What can we do here? What do we have to do?
Why is the original oxygen by two?
Multiply this by 2?
No, I mean this one. No, not that one.
Not that.
Yeah, that.
Over here? Now, I can't just multiply this though, because
Well,
if I put a 2 here,
yeah.
right, then that 2 applies to everything there. Maybe what are they saying?
I can't see it.
You cannot see it?
Mm-mm.
Let's see.
I'm on the cloud, right?
You didn't join it yet. No. Click this.
This one?
No, this one. Yeah. Done? Oh, I see.
Where?
No, no purple. And what's that bubbles? Oh. Oh, there we go. What? No chat messages. There were plenty of chat messages. All right. So, if I put that 2 there, that applies to everything on that water molecule because I'm saying there are 2 water molecules. Right? Well, wait a minute, that screws things up. Now I've got to have how many? 4 hydrogens. How am I going to get that? Don't forget, that 1 is still there. Okay?
Or like exams or like when we're doing this like creative, do you want us to put the 1 there? Or do you just want us to like?
Not unless I explicitly ask for it, and the way that I might explicitly ask for it is what's the coefficient for it? Okay? But if you're just balancing this, you put a 2 in front of the hydrogen and a 2 in front of the water, that's fine. So what happens with that is that the next process, so we just looked at this and decided the next process, you're going to need that 1 to make it work, okay? All right, so what we've done here is we just balance this by in space and basically look at it and figure out what you need, okay? To me, that's a very sloppy way to do it, and to be honest, it's the way I do it usually, okay? But I'm going to show you a little bit better way, but let's try one in Socrated. Okay. I need to do this different. I need to give you control of it. Let's see, quizzes. 2 people already put in. Sorry about that. I'm restarting it. Just put them back in again. No, that's not what I wanted to do. All right, here we go. Because you couldn't see anything but sodium so far in the whole thing there. There you go. Now you can answer all the coefficients. And right, well, this time, since I specifically asked for the ones that are ones infinite ones. Oh, good. I have a little bit of trouble getting this one too. You sign on? I mean, you're on the web. Because I actually had some trouble with that. I couldn't find it this morning. Yeah, you were not. It's decided to make it difficult to sign on this one, not like this class. Oh, did you guys have trouble parking? Probably not at 85, right? They decided to share up the parking ticket now? Yeah. Good? Oh, you're still balanced, okay. Good? No. What was your approach? What was your thought process?
Like the ending.
Okay.
And then see, like, they had the same amount as the reactants.
Does it?
No, and sodium.
So there's only just one little thing wrong. But then once you start balancing, it messes with other things, right? What'd you do?
Sodium, like.
Oh, this one didn't have it. This one was really easy. Okay, good. I forgot how easy one I gave you to start with. Okay. Everybody happy with that? Yes? Don't forget your ones. But be aware of stuff like this. Right? Apologies to have my part here. It's a trap. Right? Don't let me remember my part in the original Star Wars. Okay. What's going on here?
The oxygen looks like one of them has three, and then on the reactor, it's like there's three, but they're separate. I don't know if that's.
All right, I think I'm following you, but try to say that again. Put it all together. So what are you saying here? About the oxygen balloons, okay. What about it?
So they both have three O's on both sides. those two are like separate.
That's okay.
That's okay.
That's absolutely okay. It does not matter where they are. As long as you have the same number on the left, same number on the reactant side as on the product side. I hear some chat popping in, but I'm not like switching back and forth to check it. Remember that y'all can just yell out too. The speaker works, I think. Somebody yell something out and see if it works.
And yours said it's already balanced.
It is already balanced. Absolutely correct. So, if I give you one of these things, how do you answer it? 1, 1, 1, 1. Okay?
Does the arrow mean, is that just like,
Hey, Eric.
Yes. Does that?
So, I got a question about the ones.
Okay.
Would you put the ones like in parentheses or just leave them as the number 1 without any parentheses? Because like in the last one with the Na and the H2Os and all that other stuff, you only had to put a 2, but you had parentheses. Would you put the ones in parentheses as well? Or would you just leave the 2s and 1s open?
You don't need any parentheses anywhere with the coefficients. I think I know what you mean. When I put that one in parentheses,
Yes.
water. Yeah,
Yes.
that's not normal. I was just demonstrating that it applies to the entire molecule. Normally, you would not put that parentheses normally. We just put it like this.
Okay.
Okay, so just ones. Okay, Madeline's asking about the arrows. I'm going to use lots of kinds of arrows. Okay. So generally, and I am not going to claim to be consistent in this usage. Technically, that means a non-reversible reaction. Okay? So think about an octane molecule in your gasoline tank in your car. Okay? You put that into the cylinder, fire a spark in it, and it reacts and changes to CO2 and H2O. Okay? Now if I tell you, okay, now run the reaction backwards. You can't put it back to the octane molecule. At least not very easy. Okay? So we'll call that a non-reversible reaction. This arrow that I've used here, the double-headed arrow, specifically shows this is easily reversible. Okay? This one happens actually anytime water comes into contact with carbon dioxide gas, like in the atmosphere, some of it dissolves and makes carbonic acid. So that just means very easily reversible. The one-way arrow means non-reversible, although I am not sure that I buy anything is absolutely non-reversible, but still, it mostly is. Okay? There'll be some others too. Good question. All right. Oh my God! If you just look at this, right, and say, no, let's try some stuff to see what that's going to do. So what I'm going to do here is I'm going to give you a step-by-step process to make these easier. And this is going to be much easier to balance than you think. Okay? So these are real things for us, like the mineral. Okay? What elements are involved in peroxide? What different elements does it have in it? Water, okay, let me ask a different question. What elements does water have in it? Hydrogen and oxygen. Okay, now we come back to peroxide. What elements are involved in peroxide? Aluminum, silicon, oxygen, and hydrogen. Okay, all the same things on the other side too, right? Kaolinite, aluminum, silicon, oxygen, hydrogen. Silicic acid doesn't have the aluminum in it, it's just got the hydrogen, the silicon, and the oxygen. What I'm going to tell you to do is list the elements right under the reaction. Okay? List them first, right here. Try this with me. So write down that original formula. We're going to balance this thing a step at a time. Okay? We know we've got aluminum, we've got silicon, we've got oxygen, and we've got hydrogen. How many aluminums are on the reactant side, the left side? How many aluminums to start with? 2. Because remember there's a 1 in front of that thing to start with, right? Okay, how many silicons? Okay, so I'm going to ask you to do this for each of the elements. Okay, how many aluminums on the right, on the product side? So that one would be fine, yeah? Okay, so list the elements and then, ones. Remember your ones. Count how many of each atom there are. Okay, so 2 aluminums there and 2 on the right. How many aluminums on how many silicons on the left? How many?
3.
Silicons? Not yet. 4. 4 on the left. 3 on the right. Okay. Oxygens, that gets a little harder to count. Okay, 13 on the left. You're absolutely correct, and talk me through how you got there.
Well, we start off with 10, right before the hydroxide. And then we have the 2, but that kind of multiplies
So
over to
10 plus 2 times 1, so 12.
And then we have 1 oxygen on H2.
Okay, all right. See all that? So you've got to gather them all together. I don't care where the oxygens are on the product side. I just want to know how many there are on the product side. I mean, on the reactant side and on the product side. So we have 13 on the reactant side. How many on the product side?
Look at again.
Well, that looks good, right? How many hydrogens on the reactant side? 4. And on the product side? Oh, 4.
Wait, right?
That should have been an 8, right?
Yeah.
Yeah, I had the 8 up here. I don't know what I did with it. Okay. Everybody good with what I have done so far? Okay. Next step is to start balancing one element at a time. I didn't write this trick in. This is just this is not a rule. This is just like a trick that'll work most of the time. Is start with your metals, in this case aluminum and then silicon, but always do oxygen and hydrogen last. The reason I tell you to do that is that oxygen and hydrogen will kind of work out a lot of times at the end. So if you start with them, you're just going to get ugly numbers. All right? So just do them last if possible. Start with your metals. Taylor, something about an atomic. Tell me.
Oh, I was just saying there was 8 hydrogen on the right.
Yeah, I can work that out.
Is that an 8?
It is an 8. I'm going to get better. I'm going to get better. Yeah. You are correct. It is 8. I don't know what that was. I don't know where that little 2 came from. Okay. All right. Let's see, I had it fixed here. All right. The next step is to start to increase things to balance. What do we need more of?
That's fine.
We need more silicon. Where can we get it? We're going to get some more silicon. We're going to get some. What can I do to it? What can I change?
No.
Could they multiply the H4SiO by 2?
What do you mean multiply by?
Oh.
Change the coefficient. Right now I've got 1, right? I can have 2. Now look, there are actually 2 answers here. I could get more silicon here also, okay? But your intuition is good to go with the simpler one. We don't need more aluminum. We do need more silicon. So let's change the coefficient on the silicic acid. Okay? But you might have to trial and error of this to get the right one. Okay? So what I will do is I will mark out the 1 coefficient and change it to a 2 coefficient. Then I'm going to do a thing that you're not going to want to do probably. I want you to mark out all of the tallies on the product side and start over. I've seen a lot of students balance equations, and they don't like to do this step because it's a little more tallying work. Okay? They'll just say, oh, I just added this many. If you try to look at this as you added this many, I promise you, a lot of you will confuse yourselves. So it is safer to mark those out and start over. Okay? So, how many aluminums do I have on the right now? After changing the coefficient of it. How many now? Still 2. Okay, we didn't change the limit. How many silica do I have? Right. 2 in there, and 2 times 1 over there. Yes, 4. Okay. How many oxygens? This one's complicated. So get me there. Where are those 17 that you saw?
Okay, so you would get 8 from the, over here.
Okay, so 8 over here.
Yes.
2 times 4. Okay, cool.
So then there's 9 over here.
5 plus 4, so 9. 17. Okay? Some of these tallies will get large also. How many hydrogens? I count 12 also. You guys see 12? Okay. Well, we balanced the metals. Are we good? Do we have a total balance here? Okay, now I gotta go get some of the other stuff. So I always do my metals first if I can, then my non-metals like phosphorus, nitrogen, carbon, and then do my hydrogens and oxygens last. But so we got left here, so what would you do? How many? And where? I should say. What do you want to change? What about the H2?
Making, like, change the coefficient.
Change the coefficient to what?
4.
4?
I think so.
All right, let's look at it. Let's
Because you
see.
need 4 more oxygens to get 17.
Okay, so you're doing the adding to it thing, and that's what gets you every time. Yes, maybe you need 4 more, right? But you remember you've already got one. So it needs to be 5. That make sense?
No, I don't.
Okay, let's watch this. So if I change this to 5, right? Mark all those out, right? So I've still got 2, and I've still got 4 because I didn't change that. Now let's count. Tell me how many oxygens I have.
15.
Why do you see 15?
Because there's 10 oxygens over there.
Ah,
Oh, I didn't see the OH.
yeah, you gotta count those.
So yes. Yeah.
Okay. All right, so step by step, right? Now I'm gonna, I think, do I have a harder one in here? No, I don't think I did a harder one. I did a stoichiometry problem a little bit, but. So, you see my process here. I've got some in the homework. Some of the homework ones are easy. Some of them are less so. Okay? Yes? All right. I'm gonna insert a slide here because something I didn't talk about. Let's keep it. So, let me try to think of one that's gonna work. Let's see. Yeah, that'll work. Propane. No, let's not. Let's do butane. Yeah, that'll work. So like a butane lighter, right? You guys have used butane lighters to light campfires and stuff, yes? What that reaction is doing, it combines with oxygen to form CO2 and H2O. Let's balance this real quick. And the reason I wanted to shove this one in is to show you one more trick that's going to come up. Okay? So where would you start with this one? What do I want you to do last? Okay, and what's the other thing involved here? Okay, so we got carbon, oxygen, hydrogen. How many do we have on the left? Okay, so what coefficient would you change first?
I think there's 3 oxygen on the right. Oh, sorry. Sorry.
What coefficient would you change first? I would too, yeah. Not the only way to approach it, but I think it's one of the best ways. So we'll change this guy to what?
3.
Do it again, maybe. You're trying to add to it. How many do you need total? So let's change it to a 4. I really want to see what they're saying. Somebody watching what they're saying. You guys remember you can yell out stuff.
He said, I have no clue what this. Zach said before.
I think he was answering
Maybe he
as
was
we went.
answering
Yeah,
that.
he was answering as we went. I need a better way to see this. I don't know what that is yet. I'll fire the laptop up again and make it work again. Okay, so what can I do here? What should I do? What would you like to do? How many waters do I need? How did I get 8 of that? That's not 8.
Yeah, how did you, yeah.
I don't
I was
know.
gonna say, how did you do
Not enough coffee? All right, there's still just 2 of those, right? And that's probably what Zach's telling me, right?
that? Okay, Henry said, how would the H change when you put a coefficient on the top?
He is correct. Thank you. All right. So I do need my H's to change though. How many H's do I need total? I need 10, right?
And I keep adding.
I know. See, that is
I keep
that
looking
is
at
just
the
coming
2
back
and thinking I
on
need
you.
8.
All right. So how many? So I want to make this a. All right. So that's still 4. Oxygen's is crazy now. 4 times 2 is 8, plus 5, so 13. And now I have 10 of these. Okay. Make sure that you get to where I am right now before I do the trick. And check it too, because I'm doing crazy. Okay. Right, so everything's good, but what am I going to do with this oxygen? If I change my oxygen coefficient to a 6, it gives me 12. But if I change it to a 7, it gives me 14. Right? Is that a problem? I mean, it's like I need 6.5, yes? Okay. So do this trick. Take everything and double it. Okay, so we'll make 10 waters, 8 carbon dioxides, 2 butanes, Worry about the oxygens because we're still going to have to balance it. Okay? Mark everything out to make sure. Got 8 of these. We got 8 of these. We've got 20 hydrogens. And we've got 2 times 10, 20 hydrogens. Okay, over here now we've got 2 times 8 is 16 plus 10, right? Now I can just make a nice, okay, cool, 13. Okay? You see my trick? This trick is most commonly needed with combustion of hydrocarbons, but that's not the only place. In fact, one of the homework ones has it in another place. It's not combustion of hydrocarbons. All right? We got one more major concept today, stoichiometry. All right, stoichiometry. So what we're going to do is we're going to use these balanced equations. We're going to use those coefficients as mole-to-mole ratios. Okay? So in my example there, how many molecules of butane are there in this equation per molecule of CO2? So look at our final coefficient. How many molecules of butane did I get? Coefficient. Two molecules of butane. How many molecules of CO2? 8. All right. So 2 to 8, or a 1 to 4 ratio. Okay. And that'll tell us how those will react. Called the molar ratio. So in this case, what is the ratio of iron to sulfur in this reaction? 2 to 3. Okay, does that make any sense? So if I say, hey, I've got 20 iron atoms, okay, how many sulfur atoms am I going to need? How did you get that number? You're right, how did you get that number?
It's 2 to 3.
Therefore, you did what?
Right.
Yes, you did. Yes, you multiply by that ratio, okay? 3 sulfurs for every 2 irons. 3 over 2 times 20 gives you 30. All right. What is the molar ratio of iron to iron sulfide?
1 to 3?
3 to 1.
Oh.
Yes, it matters. Order matters here, yes. And not only this is another place that the ones matter. Okay. 2 to 1. 2 to 1. Sorry. And that was 3 to 1. Okay. Now look at the way I've listed this. I didn't say molecules. I said moles. Okay. That works. You can do that. And we're going to work in moles more than we're going to work in molecules. You can think of it in molecules, right? But remember that chemistry is a statistical science. And so it's about averaging it over 10 to the 23rd molecules, okay? Or in this case. What you cannot do, you cannot do this with grams. It does not work. You have to use moles. Okay, that's gonna be very important. They're gonna be trick questions, I promise. How many, all right, so if I ask you this one, how many moles of iron oxide, Fe2O3, iron 3 oxide, can form from 6.0 moles of O2? Everybody try to work that out on your own right quick. What are we gonna need? What am I gonna need here to work this out? It is in moles, okay, 6.0 moles, good check. Now what?
Using the reaction mode.
Yes,
Right,
using-
okay.
That's the red reaction there. This thing we just talked about with molar ratios, right? Which ones am I gonna need?
The coefficient?
The 2 coefficient on the iron oxide, okay, what else? We need one more.
Three,
On the,
reactant side.
on the oxygen, yeah, the 3 on the oxygen, okay? So, for every 2 moles of iron oxide, there are, don't finish my sentence. For every 2 moles of iron oxide, there are 3 moles of oxygen. Okay, so if I wanted to set this up as an equation, right? Well, think about dimensional analysis. How could I set this up to cancel out my iron? What can I do?
Two,
Let's just talk about units first. Just units. What went away? Okay, Fe2O3 on the bottom, she says, why? Yes, because I wanted it to go away. It's not over here on the right. What is on the right? What showed up? Man, if I just knew numbers, if I knew numbers that went with the oxygen and then the Fe2O3, do I get those numbers anywhere? Any questions? How many?
3 moles of O2 and 2 moles of Fe2O3.
Yep. So now I can just cancel that as if it were a unit. Just like our dimensional analysis on exam 1.
Could you, I'm sorry, could you read that?
Which one?
The last, the parentheses,
Moles of O2.
Here?
no, to the left, that was in blue.
It's just moles of O2. Let me check. I think I have it. Yeah, I do. I have it typed out. It'll be a little easier to read.
Okay.
Yeah.
Thanks. Thank you.
I think I did it. It's separate. I did it. Yeah. Did the other equation here. Whatever you start with, right? I didn't type this up.
Yeah.
Yeah, but when I wrote it out, I started from 6 moles of Fe2O3. This one started from 6 moles of O2. It doesn't matter, but just like Madeline said, you want it, whatever you're wanting to get rid of, put it on the bottom. So you cancel it out, okay?
So how did he get 4 moles? Like, how was that your answer?
Okay, so you're gonna multiply by the fraction, right? I think in multiplying fractions, but not everybody does. So your calculator will probably handle it pretty easily. 6.0 times 2 divided 3 should give you 4. You can think of it as multiplying straight across the top. 6 times 2, 12.
Oh,
1 times 3, so 12 divided by 3 is 4.
Oh, yeah.
Mass calculations. Now look, this is going to be a trick. You cannot use these for masses. Therefore, what are we going to have to do with our mass? If I ask you 6 moles of oxygen, we just did that, right? You just take it. But what if I say 6 grams of oxygen? Doesn't work this way. So what do you have to do? Perfect. Convert it to moles, and then you can do whatever you want to with it. So you've got the mass of species A, and you want to get to the mass of species B. You cannot do that. Okay? You have to, just like Kayla said, you have to convert it first to moles of species A. Then it's fine to use your equation to convert to moles of species B. And then you can convert back to mass. Okay? One place you see this in the news right now, if you see folks talking about tons of carbon produced from a certain kind of emission. Okay? So that's mass. We have to do all of this. We got to take the mass of the fuel that they're talking about, right? Like the octane in your gasoline. We've got to convert that mass into moles, okay? Then we can convert across the chemical equation for the reaction to moles of CO2, and then convert moles of CO2 back into mass of CO2, like in tons. Okay? You have to go up and around to get there. You cannot go straight across. And I am going to probably save that. I thought I put in a. Oh, okay. I better not save it because I put in a Socrates for that. So I can't start the Socrates without having the limiting reagent idea. Okay. So let's talk about that iron that we had followed up, right? You had 6 moles of oxygen gave us how many moles of iron oxide? Right there on the bottom. See it? Okay? Will it always? 6 moles? I've got 6 moles of oxygen. I guarantee I'm going to get 4 moles of iron oxide. What if I only have 1 mole of iron? What's going to happen to my iron? So, picture it in your head. I got a pile of iron sitting there for the reaction, okay? And I'm going to apply 6 moles of oxygen to that iron, okay? This is what this says for the oxygen, but what's going to happen before I get here? What's going to happen to my iron supply?
You're not gonna have enough.
Right?
You're not gonna have enough.
I'm not going to have enough. I'm going to run out of iron before I run out of oxygen. Okay? That's determining the limiting reactant. Your theoretical yield is what we just calculated, right? That moles of iron oxide. It's the predicted amount from the equation. The actual yield, we'll talk about that later. so think back to our lab with copper. What if I had, oh, this is from that beginning slide. Yeah, there's our copper nitrate, right? So I've got 100 moles of copper nitrate, and I've got 100 moles of sodium hydroxide. Which one of those is likely to run out first? I've got 100 moles of the copper, and I've got 100 moles of the sodium hydroxide. Which one gets used up faster here? How do you know that?
Because, the copper nitrate has, numbers,
That's what?
yeah, on the outside,
The coefficients.
yes.
Okay, the copper nitrate has a coefficient of 1. And the sodium hydroxide has a coefficient of 2. So what's the rate that sodium hydroxide gets used up compared to the rate of copper nitrate?
1 to 2?
Yeah, because the copper nitrate gets used up half as fast, right? Or you can say it the other way, the sodium hydroxide gets used up twice as fast. So it's going to run out first if you have equal amounts. Yes? Yes? Now you're not going to have equal amounts in the problems I'm going to do. There's going to be a lot of calculating involved. Yeah, we did that. So, how would you calculate? Can we do this one yet? We can do this. We'll just do it together. All right, we'll work it all together. All right, we started. I think it'll be a good practice for you to work this out. Folder is in. So what happens if the quiz just stopped? I'm gonna come down there so pretty and hurt somebody. Come on. All right, well, I'm finding so creative, or getting back on the internet, y'all tell me where you're at to start with. What are you doing to start with on this problem? Okay, we'll start with balancing. That's good. Yeah, go ahead. Let's talk out loud.
You have to make a give, silicon, coefficient of 3 in the reaction side. You can have some of the product side.
Will that work? You said a 3 here?
Yes.
That'll do it?
And then a 2.
Okay, now here, okay. Y'all hear that? Everybody got balance? Please talk to everybody else too. Everybody at home balanced? That's not it, zero. Pretty balanced. Right, everybody at home have the equation balanced. How about that?
Hey, are we doing this on Secretive or just like on our own?
You do this on Secretive, Zach? I'm trying to find it.
Yeah, like I'm still on the first Secretive that we did. Like I did it earlier and then I'm kind of just like there again, so I don't know.
It is acting up for me right now, and I'm gonna put my laptop down and walk away from it in the effort to not throw the laptop out the window. Which doesn't open, yeah, works, right? So, we're gonna not do this on Secretive, we're just gonna practice it together. Okay, balancing it. Folks here helped me balance it. You guys at home figure out how to balance it? One is going to be important. So, all right, cool. I can just use this molar ratio here with grams of silicon, right? Say it louder.
You can't use the graph.
No, I cannot. I cannot use it with grams. What do I have to do to that graph? All right, so let's do that first. How do I do that? All the stuff from exam 1 is still going to come back to haunt you. Which is? What you get?
2.67. Zero.
All right, what can I do here then?
Okay, you actually might need one more number.
Which one?
Because I think it's 5 significant figures.
Oh, okay.
I think it's
You're
after the 0, it's a 4. I mean, a 5.
Good, thank you. Oh, that was terrible.
Yeah, where did you find the 28 value from?
Periodic table.
Okay.
All the stuff that we did on exam 1 still applies. So
So the 28.085 is the atomic weight of silicon.
agree.
Okay.
Atomic weight, molar mass, interchangeable at this point. It's molar mass because I used grams per mole, but the number is the same. What do I do with these?
Do we then multiply the numbers that we got by the coefficients?
Yes. I like to do it as a dimensional analysis. So what do I want to cancel out? I want to cancel out my silicons. And I want to get silicon nitride. What numbers would go with those? The 3 on the bottom. And the 1 on the top. And you get? Wait a minute. No. What'd you type in? What'd you type in your calculator?
The 2.6705 divided by 3.
Okay. Oh, okay. So you got a 0. What?
8.
Okay. Let's do the bottom. What am I going to put in parentheses here? What am I trying to cancel out?
Wouldn't you put the same thing except have on the bottom would be nitrogen?
Agree. What numbers?
For nitrogen, you'd have 2, and then for the silicon nitrate, you'd have 1 as well.
And you divide that into 2.
Yep.
They give you that.
So, which of these runs out first? Which predicts a smaller amount? The nitrogen predicts that we can get all the way to 1 mole. The silicon predicts that we can get to a smaller amount. So that means that the silicon is going to run out first.
So would that be our answer?
What did it ask?
How much silicon nitrate can we form?
Yes. So the 0.8901 moles of silicon nitride is our answer. Okay? We can never get to the predicted amount from nitrogen because our limiting reactant is silicon in this case. We run out of it first. Okay? All right. Homeworks. I set the homework not due tonight. I set it due tomorrow night. That does not mean wait until tomorrow night to start it. I did that for a reason. Okay? It's going to take some crunching. The first part of this, the 4 and the 5 questions, those are balancing equations. The 42 and 48 are stoichiometry and limiting reaction stuff. Okay? All right, y'all remember how to get in touch with me if you need something, help you work through these. There are websites out there, guys, where you can just look up and ask it to balance the equation for you. But if you do that, you are cheating yourself, because you can't use that on the exam. So try to balance it. If you cannot balance it the way we were doing today, get in touch with me and ask me to help, okay? If you try it, think you've got it, try it a second time and then run out of attempts. Well, actually, in this case, no. This is a submit your, so there is no number of attempts on this. You just submit until you get tired of it. Okay? So submit these in the assignment folder like we did before. Remember that, Kayla, I cannot see the super secret Mac files, right? So if you have those, is it ACIC, is that what we talked about?
I'm not sure.
The extension, something's extension on it that I'm not allowed to see, because I don't have Macs. So make sure you upload it in something that I can see. All right, cool. I'll stop talking.
Did you get all of our labs?
No, I've not even started all that yet. I spent the weekend.
Hey, on that last slide, the answer was 0.8, right?
Yeah, it was the prediction from the silicon. The silicon was our limiting reaction. So
Could you
0.89.
Could you write on there that that's the answer so that like whenever I look back at the notes, like I know which one's the right answer?
Uh-oh. Apparently it won't let me. Okay. You know what? I have to go in slideshow apparently for that to work. I didn't realize that.
Okay,
How's
yeah,
that?
thank you. That's good.
All right, and I'll upload this to the website. Okay.
Can you look and see if you can see my lab? I just don't want all of a sudden you're grading it and
Yeah, I
it'd
hear you.
be a 0 just because you couldn't see it. I just want to make sure that it's there. Because I emailed it to you once, and then I also submitted on Google Review.
Yeah, that's good. That's not bad.
There it is.
Yeah. Good.
But is it in there? Wow. So I want to make sure. Oh, I guess what we're right there.
Yeah, that's good. Yep.
Okay, cool.
All right.
And that's for me.
All right. All right, folks at home, anything else? We good? Y'all let me know if you need anything else.